Less than an hour. Good.
Yeah, you see, we managed to do things in 50 minutes.
Bad clock. Very slow clock.
If it was the exam, it would have gone like this, 50 minutes.
Can I do this on the exam?
No, don't tell me. That's okay. Should be right.
Are you posting this online, sir?
I am going to post this online, yes. Good. Okay. So let us start with the basics. Okay, we have introduced sequential circuits, where we said that these circuits are meant to progress in time. So they have a memory by which we can determine the state, and then based on our design, they will go from one state to the other, and then they will produce the output at the right time. We introduced two families of sequential machines, the asynchronous and synchronous one. The synchronous one, we said that all the components are synchronized together by a clock. So there we don't have to worry about races and what have you. The clock is our timing controller. Make sure that everything is timed and the circuit will work error-free as long as timing is concerned. So we divided them into synchronous, where the operation is timed by an external clock. We use state variables to store the location of the machine in or at a certain state. And then we use some flip-flops to store the state, which could be D flip-flops, JK flip-flops, T flip-flops, and what have you. We also introduce asynchronous circuits or finite state machines. Operation is timed by input variables. So when we talk about asynchronous systems, we should not depend on a clock that's going to take us from one state to the other. The system waits there in a given state until the input changes, and then it goes to the next state. So when we look at a synchronous machine in terms of a high-level implementation, what we need to worry about is a circuit which is mainly a combinational circuit that takes the present state and the input to excite the output and produce the control for the flip-flops to go to the next state. So there are some set of flip-flops that have to be driven to go from one state to the other based on input and present state. So as you can see, both of them are coming to this box. The box determines the next state and excite the flip-flops to do that. One of the things that we wanted to learn about sequential circuits is, given a sequential circuit, can we determine its behavior? How do we do that? We call it analysis. Analysis of sequential circuits is to look at the implementation of a circuit and try to deduce its behavior by analyzing the different components, determining the governing equations of the circuit. So the state variables are stored on D flip-flops, we know that. The present state variables are the outputs of the flip-flops. So the output of the flip-flop is considered to be the current state of the system. The next state variables are the ones that go to the flip-flops. So the flip-flops look at signals that will push them to go to the next state, and they go to the next state and produce a state that will become our present state, and the system carries on. So that's how we should analyze circuits based on these kind of definitions. The inputs to the finite state machine are assigned some variables. You can assign them many variables, and the outputs are also given some variables. Now, to analyze the circuit, we have, number one, to determine its behavior. So there are two components to analysis. Always keep that in mind. One is to determine the behavior of the circuit in time. Take any present state, start from it, and see how the circuit is going to progress from that to go to other states. Okay? Your control is going to be the clock, which is implicit, and the input x1, x2, x3. Okay? So determine the next state functions y. That will give us means by which we can determine the behavior of the state and time. It has nothing to do with the output. Then represent these functions as a K-map. So we take this function, put them in a K-map, combine the K-maps to produce the Y-map, which is the functions for the different state variables, and assign the labels to state variables, and so on. Why we do this? Why we talk about assigning variables? Because we inherited a circuit from somebody else. So we don't have any theoretical framework to describe the circuit. So we'd have to take it from the hardware into state variables and state tables and what have you. Finally, determine the output as a function of the present state and the input. Right? And you know what? If we don't finish today, we can meet another time if you want. But let us do whatever possible for now, just to make sure that we make use of our time. You have already spent 1 hour here, and it's not fair to go home. And, so let us make use of our time as much as we can. So given a circuit like this, and the question is analyze it. How can we analyze this circuit to determine its behavior? So as you can see, the circuit here has only one input X, and it has only one output Z, and we need to analyze it. So what does it mean? It means we need to determine its state table or state diagram and how much states or how many states that we have, and also determine the output for each state and so on. So now we look at the circuit here. It has 2 flip-flops, which are D flip-flops. So we just have to go and determine the values of the big Y's. These big Y's are the next state. Why? Because these are the ones that are going to excite the D flip-flops to go to the next state. The small Y's are the small or the present state. And this is the output. So by looking at Y1 here, we can determine that its function is it's a function of X, small y1 and small y2. So we know that y1 as an X state variable is driven by small y1 and small y2, which is the present state variables, and X, the same for y2, and I have the value for the Z. So when you look at this circuit, is it a Mealy circuit or a Moore circuit? Mealy circuit, is that right? Because for it to produce the output, it needs to have the present state awareness as well as X. So it's not only the present state that determines the value of the output, so therefore we can say it's a Mealy machine. So now, we bring the variables that we have y1 and y2, we just put them here in a kind of map. So we can tell that the y1, big y1, which is the next state variable y1, behaves as a function of the small variables y1, y2, and x as such. Okay, so it is only one in one specific situation. So I have now the behavior of y1. So, which means by combining y1 and y2, I can determine the behavior of this machine, given that I am in a certain state 0, 0, and my input is 0. I know that my next state is going to be 0, 0. You see, this one is for y2 and this one is for y1. And I can tell that my output is this. So this is one step in the analysis. Now, we can just take the y1 and the y2 and collapse them together into one table here, which describes the behavior of the big Y's, which are the next state variables, as a function of the current state and the input. So now, I can build my circuit, or the state diagram of my circuit,